There we go. Wait. Yes. Hello, it is April 20th, 2020. It is a Monday, and I hope you're doing well and staying safe wherever you are. Today, we're going to be looking at using the APIs for Google Cloud Storage and Firestore to design our file management layer. So using APIs isn't always easy, but it also doesn't have to be hard. So today, let's integrate some API calls. And this one. Hello, and welcome to Adventures with Yufeng, where we explore new and interesting concepts, tools, and ideas live from my webcam to your screen. My name is Yufeng Guo, and today we're going to look at how to get our cloud storage code and Firestore code out of this Jupyter notebook and into something a bit easier to maintain. My notebook's code is always a mess, as it should be. So today, let's clean it up, and we'll turn it into something that's more usable and easier to deploy. it is Monday, so if you're joining me, thank you, and I'd love to hear from you. Say hello in the live stream, in the live chat, and let me know what you got up to over the weekend. I baked some banana bread, so I'll be munching on that throughout today. So let me know what all you all got up to. With that said, let me get this thing set up here. Move over to our coding view, and some of you, this might look familiar. Hey, Rajan, welcome, and thanks for tuning in again from London. He baked cookies. It's awesome. What kind of cookies? I would be curious to know. Let's see. I got 2 Jupyter Lab environments now that I'm trying to deal with, and I'm going to narrow it down to just the one at some point. I was trying to make a Jupyter TensorFlow 2 environment, and as you can tell from the naming, I was going for that. Unfortunately, I made a bad click, and as you can tell, I still have the same environment. And then I mounted the persistent disk to the other one, and then it was a mess. Chocolate chip standard cookies, with Smarties. Very nice. Smarties in the chocolate chip cookies. That's awesome. And for people watching from the US, it's worth pointing out that Smarties over in England and in the UK is not like the Smarties in the US. It's not a hard kind of powdery sugar candy. It's actually more like an M&M. It's like a chocolate candy with a candy coating. Chris Wilcox joins us. He writes sixlets in the US. I'm not sure what a sixlet is. So Chris, you'll have to help me out there and expand on that. What we're trying to do today is last week on, I want to say either Monday or Wednesday. Smarties. Yes. Smarties in the US is different from Smarties in England. Did I say something else? That might have been my bad. And what we had done was we got our images from the Open Images dataset, and I wrote up this notebook at that time where we pulled in the CSV, we looked at the files that were attached to it, and we wrote all of this code to upload the images to Google Cloud Storage. And so even though I tried to do my best to make this a function so it would be easy to push out later, there are a lot of pieces here that are not going to be really good for I'm not going to run this notebook in production, right? That would just be a no-go. And similarly here in Firestore, this was a great experimental kind of test bed, but it's not going to serve us very well when it comes time to run this in a kind of on-demand manner, because the design that I'm trying to go for here is one where we have our images, like all of the images, in one place, but it's kind of a secret place, right? It's not meant to be the place that it will be accessed by our production system, by our machine learning model. And what I want to do is I got to move the data from this the real original data source and kind of trickle it out, stream it out to somewhere else. And so the way I've got this set up, at least for the time being, is I've got the whole data set on a persistent disk on one of these 2 machines. I forget which one. I think it's on this one now. I've moved all the code over, and I want to say it's attached. So we can check that ls block, right? So it's there. It's not mounted though, which is interesting. I think I didn't include the mounting scripts on this second VM I made, so it doesn't auto mount when the machine reboots, which happens if you have a GPU attached to it. And so I'll have to do that. But the point being, I want to take the data from the persistent disk and upload it to cloud storage, and also kind of make a note that it's been uploaded on Firestore. So basically, we'll take file. Let's see, the image is on a persistent disk PD. Then we'll upload to GCS, Google Cloud Storage. Then we want to mark the file as viewed, basically via Firestore on Firestore. Okay, so in Firestore, what I've started creating here is this collection. I'll make this smaller. of, I called it open images. And the way I'm structuring this is each image file name, including the extension, is going to be a document. And then within the fields, I'm calling it the shard, basically the folder that it is sitting in, because the training data sits across 9 different folders, train 00 through train 08. And I need to know where it is so I can go get it, rather than kind of searching through all the folders. And then visited, I originally had that as a Boolean. I decided to do a number because what I realized when I thought about it is later on when I want to use this data, all I want to do is ensure that any given model has not seen, will not see the same image twice, right? Unless I'm choosing to have it cycle through the same epoch. But I don't want the original kind of data set as the model sees it to have multiples of the same image in it. And so the visited count will enable me to not have to go through the entire collection of literally 1.7 million images and flip that flag for all of them. And instead, I can use Firestore's kind of querying functionality to find when I have no longer have any visited equals 0 values, and then basically set the new 0 as 1. And then start incrementing from there. And when I do that, I'll reset the models and things like that. So everything starts out from scratch again. So it kind of tells me when I need to destroy everything and start over, but without actually having to erase everything and then rewrite everything, because that's super time consuming. Speaking of things that were super time consuming, as you saw here, there's a lot in here already, right? I'm scrolling down and it's probably not even all loaded into the browser. I started pushing them all in. The idea being that when it comes time to move a file over, I'm just going to look it up here. It's already going to be here. It's going to say visited 0, and then it'll tell me what shard to go to get it. This will give me some ability to pseudo-randomly grab images rather than going in order through the folder structure of the persistent disk itself. So the plan is to have the image in the persistent disk, right? And when the time comes, you go to Firestore to get metadata, namely the shard, right? Shard or the folder name, and then we'll upload it to GCS. Then we'll mark that file as viewed on Firestore. So this visited count will increment visited. I'll mark a +1 on Firestore. And then once it's in GCS, my plan is to have GCS trigger, use a GCS trigger to PubSub messaging. So PubSub is Google's publisher subscriber queue system, and it will allow us to have files that drop into a specific bucket trigger a PubSub message to be published. And then downstream subscribers, which can be multiple, will then be able to take some action. And so these are short messages that basically say, hey, a new image has dropped into this bucket. Here's the path and the file name that that image lives at, and do whatever you want with it. So we'll have something, I don't know, maybe a cloud function or something, then manipulate that. And so that will kind of define our boundary between the behind the scenes stuff versus the production machine learning environment, right? That serverless machine learning environment. And so all the stuff we're doing now is essentially behind the scenes work, because this is just emulating a real environment. In a real situation, we would be streaming images from a real data source. Maybe there would be new images coming in from your users, from maybe it's from like traffic lights, traffic cameras, things like that, or security cameras, things like that. So we don't have that, right? I'm not going to hook this into something like that. So I've got to take images from a open data set and emulate that type of behavior. I also want to be able to control that kind of fire hose. I want to be able to turn it on and off, turn it up and down, so that I can basically stress test and load test my system, as well as turn things off when I'm not actively doing stuff on it. So it's not just blasting it 24/7. So let's see, with this plan and with the code that we have, I think we have everything we need to get started here. Oh, banana bread is a little dry. It was not flowing when I was pouring into the batter, so I knew this was a risk. Open images, cloud run. What was, I think, yes, this is the mount a disk to a place. I want to say this path already exists. Well, that was a useless command. Why is it? Oh, yes. Sure. There, it's an empty folder, so of course there's nothing. So that's already there. We just need to mount it, and then we'll cd into it. So I'll just go straight in. Actually, you know, we probably don't even need the change mod on there. Oh, right. This again. We need to create the mounting stuff from the actual command line, not from Jupyter, because Jupyter is not the right user. I have to do it from my own user. I just hit reconnect. This has been up for, you know, over the weekend and stuff, so I don't know if this connection was still going to be good. We'll see. Maybe I'll have to click into here, and then if this turns out to not work, I'll click into there and then hit SSH right here. Ooh, it says it's taking an unusually long time. Oh, it worked. Okay, great. Paste, mount, cd, mount, disks, open. Great. And now we have all of our kind of folders that we expect. Yes, can you not do the mount in the metadata? I absolutely can do the mount at startup. I just forgot to include that in this particular VM image. I actually even have the commands here. I made the second, this second VM, and I forgot to add that basically. So that was my fault. Here we go. So these are our things. I don't know why it's so long. Oh, it's because it's a mounted drive. Let's just do ls. So yeah, we have our test, train, and validation images here. And let's, for the time being, pull this code out as, where is the one that we're looking for? This one. Pull this code out as a Python script. It'd be nice to still be able to edit it in here rather than having to edit on the command line just for the visual nicety of it. So what I'm going to do is I'm going to hit plus, and instead of a new Python notebook, I'll go down here and basically choose a text file, and I can rename it as a Python file here, I hope. Worst case, I can always, yeah. So call this image uploader .py. Seems to work. Import. Yep, and the keyword detection is also working. So let's see. We're gonna pull in some of our imports from various parts of this notebook. Oh, I guess we probably won't be using pandas in this script itself. That was silly of me. Let me close this. Okay. So this was our initial analysis of the CSV. Yeah, we're gonna need these system paths probably. Oops. We're gonna need cloud storage. We're gonna need to get Firestore. So that's in the same package. So we'll just do that. And what else? That might be enough for us for now. I also did some timing things. What I wanted to mention earlier was I started putting all these in, but I ran it from the notebook. And what ended up actually happening here was I pushed it all through and I tried to time it to see how long it would take. And basically it shut down on me. Like, I don't know if it was because my laptop went to sleep. I hope that's the reason, and not because the VM was terminated or because Datastore or Firestore decided to just give up on me. And I did a bunch of experiments with kind of Firestore's API calls that we'll be able to talk through as we port over each piece of this code. So to get us started, let's put in some of this code. Well, let's put in this function, right? So that's at the top level. We can have this, and we'll see how it grows and determine from there whether it's worth turning this into a class or not. It's possible, but it's also possible that our the complexity of this is just not big enough to warrant that. Let's see, we have this. Let's see what we have over here so far. We have our client. The split is kind of whether it's train, validation, or test. For now, it's just hard-coded to be this folder. Right now, once we change it, it will go to Firestore and fetch the shard value, right? Because this image name is going to basically be something like that. And so this function needs to be able to take this string and then get the shard from it, because the idea is that the caller is not going to know what shard it came from. And so I'm trying to do a little bit of separation of concerns here. And so let's see, we have, oh, this storage client is created in the function. So I'm gonna, it's an open question whether we should have this in the global space or not. If this is something that's kind of long running, it'd be nice to have the client there and ready, and then we can just like get the bucket real quick. Or we can even get the bucket in advance, and then we'll just have the bucket. All we have to do is do the upload. So I'm gonna delete this for now, but I'm gonna make a note here that client creation and bucket getting this might be worth being a singleton, basically, right? A singleton pattern where you have the thing and it just sits there, rather than having it be created and then destroyed with every single call of this function. I suspect that that's where we will end up. The split, the local file name, and we're joining that. It's interesting that the split is just train. Oh, well, so it would just be train / local file name. It seems like it would be missing, okay, blob, oh, I see what it's doing. I remember now. This is the thing, not documenting enough. So this is the path in GCS that the image will live at. That image will live. So here in cloud storage, under train, so I still need to make the differentiation of train, validation, and test, but within GCS, I want this folder effectively to be a unsharded, just flat list of all of my images. So we lose the concept of what folder it came from once it goes to GCS. And that's why we need this Firestore mapping to save where each image kind of maps to in terms of which folder it originally came from, so that when we go and look it up, we can find it in the persistent disk. So then we have blob, the path. Then this is just for opening the local one, so the containing folder is going to be important there. Here we're assuming that we're already in the train folder. We'll have to make some decisions about kind of where this is going to run from, right? And so that's what this helper function with the containing folder should be able to handle. Since it knows the split, we'll pass the split in. It can then, in the here, right, we go to cd train images, and then we see that it has all of those folders. And so it'll be train images / train _00 rather than potentially, right? Train images / train 00 / something like this. rather than it being just the last part, which is, because then you're assuming you're in the training folder, which you're probably not in if this is going to be generic enough. And so we're going to read the files, and then we're going to upload, and we need to handle exceptions. So I think I might still have, I might not, some of the tabs open from then. I'm not the best at closing tabs. Let's see, I don't need that list of mappings. I might have to just reopen the cloud storage. Yeah, that was from Friday. All right, let's see. I want to, let's open the GCS Python client. GCS Python. Wow, that's a funny set of autocompletes. I mean, yeah, we want to upload the file, but I want it to handle, I want to see what they have in terms of what exceptions it throws. And we are calling Blob Upload. So let's go to blobs and resumable upload. No, we are not looking for resumable upload. Upload from string, that's not quite it either. Let me just copy this. Upload from file. Great. What do we got? That's interesting. You can take a client directly. How am I passing this in? Upload from file. The blob. Oh, I see. So ours is the client gets the bucket. So then the bucket knows what client it's from. And then when we make this blob, we're saying it's in this bucket. So that bucket then pulls in the client information. So then when we upload, it already knows all those things. So this one doesn't have any example around error handling, unfortunately. It raises Google Cloud error. There's a generic error for you. All right. So let's say for the time being, we're going to leave this out. I'm a little bit nervous about that. Specifically, I'll make a note of where it is. I'll click on, can I click this to paragraph? Yes, there we go. That gives me tags it. Then I'll at least have an easy reference to find it if I do decide later that I want to go poke around on this. But for the time being, this should be adequate. I think we need to work on this containing folder function now. Let's see, def get shard, right? So that's going to get the shard from Firestore, and from our previous notebook, let's grab some of that Firestore code because we also want the various pieces surrounding kind of getting and setting the value there. So we have our Firestore database client. So back in the day, Firestore was, commonly you just save it as DB because of the Firestore database. And I tried a number of different ways to get and set the query or the documents. I think this is what I ended up on. So we're going to run through the data sets, insert each image. Right. So this was kind of when I was trying to insert all of the image paths into Firestore so that I'd have that kind of annotated in there. With the set image info, it is kind of the setter, just the default first pass. So this will come out. We'll put that here. Oop, too far. And limit visit. So this is for when we want to visit a given image. So this should have the information we're looking for. This is the tricky thing about looking at previous work. It's like even just a week later, I'm having a hard go of just trying to remember what was I doing again. I'm looking at these test calls. So I made these 3 test calls. I can visit image, and I passed in just the string name. So that looks promising. And it then knows to go into there and get it. But what we care about is actually the setting. So when we want to upload an image, it's already in the upload GCS. It's already in Firestore, right? So we're assuming that it's already there. So if it's already in Firestore, all we need to do is grab the shard information. So that's a subset of this task. We want to mark the file. So this is kind of, yeah, part of visiting image should be getting that information. Now, whether to separate it out or include it is an open question, but let's just call this get shard for now. I'm going to move this down to here. And we'll say when we want to get the shard, we're going to do, we know this, and we have this collection name, which should be a fixed string. Put it here for now. This could make a nice little class wrapper. And when we call this, it'll look something like get shard image name, and then this should return containing folder directly, right? Because the shard value is something like train_00. So if we look at this, we concatenate the open images / the image file name. That'll get us this document, right? So this is what we see here when we were when I was experimenting with this. Where is it? Open images, and then you get something, and then we can fetch it. Right, you set it to fields. So if you call this line, right, the way it works, as I understand it at least, is we do db.document, and then this doc name has our open images / the image name, which is what we have here, open images, and then the image name. So that's kind of the fully qualified path, if you will. And then you have to call get to actually get it. And then it comes back as kind of this encapsulated object. So then we say to dict and grab, and then we'll have all the fields. And so the field that we care about in this case is shard, right? Shard. And that'll get us the string. And we see something similar being done here, where I'm grabbing the visited field and where I'm trying to create this control system, basically, where if the visited is greater than the limit, I'm just going to return and not increment the visited. But if I am not at my limit, I'll kind of increment it. And I probably should return something like false here, as in it didn't increment, versus here I'll just return true. We'll see if there's anything else I should be returning rather than just true or false of the success. But you can imagine calling this now with just like if visit image, and then you can proceed and upload the image and things like that. So we're going to get the shard, get fields.shard. This should just return. Of course, this is no error checking in terms of very much assuming that it can find this document without any trouble. I did experiment a little bit with what happens if there's nothing. It just comes back empty. So this to dict, I want to say will still work, maybe, or maybe get will come back empty, and then you have to handle it from there. Do I have an example thrown in here? Maybe not. Quick question from Rajan: where do you get the shard info from Firestore? Where did it come from in the first place? That's a good question. So this is coming from a kind of pre-run job that I still have yet to truly run. I tried running it basically earlier. This is what these two are supposed to do, namely this function, set image info. What I want to do is run through the entire data set, all 9 folders, all 1.7 million images, and insert every single image into Firestore as visited 0, and then encode that shard value. So you can see that here. I've encoded that, and I grabbed that from the file. And so I tried running that in Jupyter Notebook right here. I made this loop where I said, basically I did a little OS walking, grabbed all of our 9 folders, and then wrote a little function that gets all the image file names within each folder. And so here I did a bunch of tests with breaks and stuff, but essentially I'm calling set image info, right, which is that Firestore call from above. And within, for each file images in the file list, I'm doing that. And I'm getting that file list from this helper function, that's this one right up here. And then I'm going through every single folder. So for each folder, within each folder, for each image gets set. I'm going to have to factor all of this out as well, is what I'm realizing. So thank you for reminding me, because it didn't finish. Right? I think my computer fell asleep. And so we'll pull that out as well. But for now, I have enough to work with that I can kind of like get this up and running first. So we have, let's see, uploader. Let me make a little space here for the Firestore stuff. And get shard. Let's just say this will work. And I'm pretty sure there's a number of missing parameters and stuff. This is the tricky thing about migrating off of Jupyter Notebook, is half the stuff that's in here I don't necessarily know if it's not as tested, right? So let me go over to the command line prompt, and let's go, well, this is a different folder. Let's use this command line prompt, since this has access to, it's in the home directory already, so that makes it easy, specifically the Jupyter home directory. And so we care, it's, where is it? Convert, yes, image uploader.py, right? So we also haven't added anything to do with, the if name equals main. I can never get this right. So some things are easier to copy paste, just because A, it's faster, and if only I can, great. And then I'll also probably copy paste some of the, how far off was I? Yes, I wasn't sure if there was a, great. And then we'll do the args parse, because what's gonna happen here is eventually this will go into like a Flask server, which we kind of started working on with Dustin on Friday. We have this kind of nice little Flask web client, and right now it goes and gets predictions from the cloud ML AI platform predictions, rather, custom model, and we just like can upload a file and then hit submit, and it does that. So it's like not really what we're trying to do here at all. I mean, it will be down the road, but for now it is just kind of scaffolding basically. So I'm wondering if I shouldn't just start pushing code into that directly. We already have the workflow kind of set up for that. Did I do that? Oh yeah, I did that from the command line in VS Code. Yeah. Well, let's try it here for now. What I can do as a little tester. So what we can do is, let's test, for example, get shard image name, so we can comment this out, and if we can test this get shard functionality. We have a image that we were using. Let's say, I don't know, how about this one? And so what we can do is we can call, I'm not going to call get shard directly. Let's do, where did it go? Set image info. What's nice is, because this is all one project, not set image info, visit image. Because this is all one project, we can, all the keys are set up in the notebook environment for this kind of service account, so it's like pretty straightforward to use. Visit image, and this will return true or false. Should I just use the same test code I was using before? I could do that. Set image info, and then what we can do is, the thing I'm mulling over now is that you know, this is the conveniences of Jupyter, right? We have these like global scoped DBs, which we kind of do in the script as well. Let's do that for now, just as like a kind of hasty version. I'm gonna test visit image. Make a little test function here, which will call set image info. So we'll set some value. Let's just call this test.jpg to make it clear what we're dealing with. And then, well, we shouldn't do that because the images actually line up to specific images in our folders. And then it will insert this dummy kind of value into our Firestore database, and then we'll be able to kind of see it. So let's print this. Whoa, I just changed thing by accident. Okay, and then after we have that, let's copy this out, see if we need to make any modifications here. Add the prints. And so this is visiting that image. And in visit image, we kind of try to find it and then increment the visit count, after which we should see that the visited count increases. So I'm just dumping out the dictionary. Obviously, we could grab it from it more directly, right? So let's see. Then when we're done, this is end of test. Basically, we want to delete that entry so that we can have a test that doesn't affect the outcome. And this should allow us to see if this change of this new kind of get shard function is working as we expect or not. Specifically, I lost it. Where's get shard? Up here, yes. Oh, that's in the upload image. Okay, so then we want to call upload image. May as well round out the test, right? And then we'll give the image name. It'll be the same. So before we delete it, let's upload this. And once it's uploaded, we should be able to find it at this location. Let's confirm that it's not there right now. And if it is, we can delete it. ls-l gs:// paste it in. I don't think I uploaded it. It says that this VM doesn't have, so the service account doesn't have access because it's not authenticated as me. So if I run, but if I do it from my local terminal, it'll work. Or if I do it from here, it'll work. gsutil ls-l gs://. Huh. Oh, it's the same compute account. Weird. Am I doing something wrong here? Oh, it also didn't copy paste correctly. Whoop. I know what I'm doing wrong now. It's not called Open Images. It's Open Images v6. Open Images is a Google Cloud Storage bucket. It's just not my Google Storage bucket. I called the Firestore collection Open Images. Oh man, this is gonna trip me up so many times in the future. Like, this is the collection name, and you'll see up here, GCS bucket is Open Images v6. So it's absolutely that. And I think everything I did would have worked, quote unquote. Yeah, at least this, that's right. Rajan says, at least the security works. Gabe says, I can't tell you how many times I've gone back and forth renaming my collection, bucket, and schema. Isn't that the truth? And it's not 6, it's v6. Yes. Come on. Okay. As we had hoped, we don't have the URL. Let's test this thing, make this happen. Where did it go? Let me save this. I should just be able to run it since I'm already calling it. I'm not going to deal with the passing in arguments thing because we got enough stuff on our hands. Image uploader. Oh, right. Python image uploader.py. And great. We've got some errors. We have it found the shard, it incremented it, and then in upload image name is not defined. Great. What line did it say? Was that 63? All right. Well, that's what I get for copy pasting it. This is our image name, which at this point I've typed way too many times. I think we're gonna abstract that out. How about calling it image name? There's a way to solve your variable unnamed problems by just naming the variable and then replacing all of your hard-coded magic strings with that variable. And because we're using Python 3.7, I can do f strings. Boom. Lovely. And this is the same string. Yeah. And so is this one. Okay, fair enough. Let's call this the Firestore path. And do this. Man. Feel like, yeah, a lot of times, right, software development just ends up being how much refactoring can you avoid / do and save yourself a lot of headache. Because that also guarantees that I'm deleting what I thought it was, right? Like I'm using the same variable every time, and if I change a string later, I might shoot myself in the foot again. What did I do wrong this time here? Take 0 positional arguments, but 1 was given. Curious. Get shard. Yeah, I think it should take an argument. Collection name, image name. Today you learned about, 3.7 and above. It's pretty awesome. It's similar to the JavaScript, modern JavaScript changes to allow you to put, you can actually put any expression here. Like you can do manipulations and stuff too. So f strings, really handy, much cleaner. Big fan, in case that wasn't clear. And Gabe thinks feels he needs to reformat all his Python code. I feel you, man. Like when I first learned about f strings, and then it turned out Jupyter Notebooks, the ones that we had on AI Notebooks, didn't support Python 3.7. It was 3.5, which didn't have the f strings yet, and it was really heartbreaking for a time. So to get our shard, we need to know the collection name, which is a global, and we need this image file name. And so that's what I should have included in the arguments. It's funny, I like used all of my methods correctly, right? But like I didn't name them correctly. So we have our visited, we increment, and you'll notice that the dictionary returns not in the same order because it's not an ordered dictionary. Chris mentions that another cool thing that could be used here is pathlib. Pathlib. Let's take a glance at what that is. Detours. Pathlib, object-oriented file path systems rather than using OS. You can do path dir / file. How does that work? See, now I'm really curious. I'm worried this is going to take us down too much of a side journey. Might have to say this for another thing. So what do we got? If you make a path and it overrides division, oh my gosh, wait, what? You're using literal slashes outside of strings to navigate the directory tree once you kind of create this path object. That is very clever. Like, I am glad that this exists. Like OS path is like it's just been around so long, right? So everywhere you look, you pretty much see that. But much like other modern languages, I think a lot of languages in recent years have developed a ton of new features that we haven't necessarily been able to keep up with. For low-level manipulation, you can also use OS path, but since we're not doing super low-level stuff, you don't have to. This is very cool. Yeah, I mean, it's like f strings, but what it's doing is it's putting slashes. It's doing this string divided by this string. Like, it's actually really funny to look at. But yeah, making everything much easier to read, much more semantically sensible. What I sometimes worry about, of course, is that these things will, New features like f-strings. Yes, I know it's not that old. Yeah. C++ overload operators. Rajan pipes in. I have not looked at modern C++ in so long. File uploaders. What am I doing wrong here? No such directory. Oh yeah, of course. I'm not in the right path, right? This isn't the directory that I'm supposed to be in. So let's set it manually for now. Hopefully this doesn't come back to bite me later. But famous last words, right? Okay, so this is our path. It's looking for, it is looking within train only. So that's interesting. Let's see, line 21. And so when it tries to upload, it's failing because the containing folder is just the shard information. We're not actually taking into account the split. So get shard should also have the split. Let's include that in this little bit. You know, actually I'm not going to do that because get shard is concerned only with the Firestore side of things, and I don't want to pollute that with local file system stuff. So I'm going to keep that in this upload image system. So the containing folder, that'll come back as train 00. And what we want to build out is the full path. Path to image, for lack of a better term for now. Like we want this to be something like train in, actually I think I have it, come on, there. And then we want this to be after that, and then we want the actual image to be after that. So that's what we want. I'm gonna put that up here. Okay. Okay, so we have the image name. So we actually don't want this part because we're going to join the, what is it joining? What is split? Oh, train, right. Okay, that's the blob. What we care about here is for the upload. Containing folder and the local file name gets joined. So we're going to need this bit, so not this bit. And so that's going to look like path image is, let's assume we're in the mounted directory, and that might change, right? So, but it's always like train, test, or validation always has underscore images afterwards. It's a little bit of hard coding, but you know, split underscore images, that's this piece. And then we have the next part is if we were using pathlib, let's just throw it in there for fun. What is it? Import path, and we're going to make a path navigating inside a directory tree. Okay, so yeah, it's just the working directory. So, all right, Chris, you win. Path equals this thing. Let's see if I'm using it right. You know, trying a new library for the first time on live stream. What could go wrong? And then we say, oh, that doesn't look right. Path, yes. And we're going to say this is our path. And then I'm going to say root split images slash. Are there any syntax? It's just strings? You're just slashing against the strings? That's crazy. Man, how do we get the string path out of it? Or you can just use it? Any thoughts, Chris? Can I just use it directly, or will? Oh, okay, I can just stringify it. All right, take it. And then later we'll do string on path to image. Oh, you think we can use it directly? All right, well we'll leave this. We'll see. We'll see. Path image, and then we need the containing folder. Right, we can cast a string. Great. And containing folder shard. Yeah, really, it's just the shard name. I mean, we can. This is only going to use one, so I'll probably move it down into here later. Path image is what we really care about, though, and so we're going to put that here instead of containing folder. save, and we're gonna do it again. Run our little test suite. No such file directory, train images, train. Okay, so that is the right place. We are in the right, oh, we're still in the wrong folder though. Let me, at least it's looking for what I feel is the right thing. So that's a good start. This is where we want to run it from. We're gonna move it up to the train images path, and we're gonna, but now the image is in the wrong place. Fine. Let's just do it this way for now. I will hard code the path from which it should run, and then it will work. Let's confirm that it worked by going to cloud storage, or actually we can just rerun that GCS thing that we did earlier. Where did we end up running that though? Okay, it's here. v6. So this should exist now. It does not, because it's at /train. And now it's there. That's great. So we can see that it was uploaded, and moreover, we should also, I mean, we saw that the value is grabbed from there. So we sort of built a thing. It's still far from anything you could consider remotely production ready, but it's not nothing, right? We've moved it out of Jupyter Notebook. It took me an hour, learned about the path library, showed Gabe F strings, so that's something. I got 1 byte out of my banana bread done. I guess 2 bytes soon. And next step here, I think, would be to figure out some more of these intricacies around where am I going to run it from, what path folder is it going to be expecting. I think at this stage we might be ready to start integrating it into our app, right? Our little Flask app, and kind of investigating how to make sure that it can reach the file system, because a cursory search, a cursory search of the internets around kind of it might not be in this folder, but I was looking just a little bit ago. Persistent, this is like one of those things where it's like, why didn't I think of this earlier? Persistent disk, Cloud Run, and it's like, oh, Cloud Run doesn't allow you to attach persistent disks because it's a stateless service platform, right? And so what can we do to get it access? And I also noticed the camera is a little bit out of focus. There we go. So we might need to reconsider what we kind of run this on, right? It's in a Docker container, so we should be okay. But we might have to mount it to GKE, for instance, or Knative. So it says persistent volumes with persistent disks. This page provides an overview of persistent volumes in Kubernetes and their use with GKE. This page focuses on storage backed by compute engine persistent disks. So this is absolutely what we want. It might mean a little bit more work to get things going. Maybe if my understanding from my colleague Brett is accurate, we might be able to get away with using something like Knative, which will help configure a lot of this Kubernetes stuff for us. It's like in between Cloud Run and Kubernetes, and it'll allow us to do a little less manual work of configuring this, assuming that it gives us enough control to actually mount these persistent disks, because it'll be really nice if we can spin up a cluster and have all the instances be looking at the same persistent disk, same read-only persistent disk. It actually might be a pretty good infrastructure. So with that said, that's our hour today. I'll be back on Wednesday, same time, same place, and I hope to see you there. We'll be probably moving things in the Kubernetes direction, trying to get some of this code sorted out and pushed up to properly put into a Docker file, packaged up, just something at a minimal level, right? Just like being able to do something with it. And at that point, we are in a position to start running that long-running job, right, of writing 1.7 million records to Firestore and kind of setting it as 0 visited and marking the shard values, at which point then we'll be ready to proceed with kind of this streaming operation of uploading it to cloud storage like we did for that one image, but moreover, we can then put in, all the images, not all, but like as on demand, basically this on demand system. So that'll move us toward building a web front end where I can basically click a button to like basically say, get me an image, get me an image, get me 100 images, get me 100,000 images, and have that be streaming through PubSub, leading to whatever the next kind of thing in the pipeline is going to be. So looking forward to that. Thank you, everybody, for watching and joining, and your applause is heard. I actually, on on the live chat here, this emoji is not clapping; it's hand washing. And when I mouse over it, it says "wash hands." I guess I need to wash my hands. Wash my hands of all of this nonsense, right? Anyhow, I hope you enjoyed this, and it's a tiny wash hands, or is that a clap? Gabe wrote in with a miniature. Can I? Oh, weird. When I mouse over that one, it doesn't give me the hover text, so I actually can't tell what it is. I assume this is the actual clap. So that's funny. Anyhow, with that, I guess all we got left is the outro video, and I look forward to seeing you on Wednesday.